everybody, we are going to look at pyramids, and today we are just going to focus on rectangular pyramids. So pyramids that have a rectangular base or a square base. So just a quick reminder that surface area is the surface or the area. Oh gosh, that's just terrible. Okay. The region you can paint, right? It's the outside of a pyramid. And it's all of it. So it's all of the faces and the base. The lateral area is the area or that region you can paint without the bases. All right. And obviously these are not definitions. The definition of a lateral area is not what you can or can't paint. But I think that explains the idea. Without the bases, the base of a pyramid is the non-triangular face. Now, if all the faces are triangular, then it is a triangular base, and that's okay. But when you have a face that is not a triangle, that's the base of the pyramid. And the volume is the 3D measurement for measuring how much you would need, like maybe liquid or water of a pool or something like that to fill. So measurement of space is what volume is. Okay, so a rectangular pyramid has one base. It is a rectangle, and that can include squares, remember, because a square is a rectangle. The number of lateral faces, because our base is rectangular, right? It's going to be rectangular, something like that. Then the number of lateral faces is going to be 4. Now tomorrow that's going to change because we're going to change our base. And the shape of the lateral face will always be a triangle. Okay, so quick review on that from the first day. Now we're going to introduce a new variable when we are talking about the formulas for pyramids, and that is going to be this lowercase cursive L, which represents slant height. Okay, so slant height. And this is the height of a lateral face. So it would be down the side of the pyramid. So let's see here. I'm just going to make myself a triangular pyramid. The actual height of the pyramid goes from the vertex of the pyramid and is perpendicular to the base. So that green segment that lands in the center of that triangle is the height. The slant height is like if you were sliding down the front of this pyramid, okay, that is the slant height. And that is this lowercase l. So that is called the slant height. So the height h is still the height of the solid. P is still the perimeter of the base. I'm working backwards, which is driving some of you crazy, sorry. B is the area of the base. V is the volume. L is the lateral area. And S is the surface area. So the formulas, now we have to be, let's see here, we'll start with volume. So if it comes to a point, if it's pointy because it's a pyramid or a cone, then it is still the area of the base times the height of the solid times 1/3. Now what you have to be careful about is that you're using the actual height, and the height is still perpendicular to the base. Okay, the slant height is perpendicular to the edge of the base, right? So it's perpendicular to the edge of the base, but not the area of that whole base, or that whole base as 2 dimensions. Okay, now for surface area and lateral area, you can only use these formulas if the base is regular, okay? So for lateral area, you can use the formula 1/2 times the perimeter of the base times the height, okay? Or you can draw a net. All right. For the total surface area, we can add a base to our lateral area, okay? Or we might have to draw a net. So if it is in light blue, you can use the formula when the base is regular, okay? So if you're using the formula, the base must be regular. And we'll see this in an example. Okay. Otherwise, if your base is irregular, like a rectangle, you use the net. You have to use the net to find the surface area in the lateral area. All right. So use the net for surface area and lateral area when your base is irregular. Okay, so we'll update the formula sheet right now, and then we'll take a look at some examples. All right, so like I said, you can use the formula if your base is regular. Like this pentagon would be regular, so we can use that formula. Otherwise, you have to use the net, and we'll see this in a minute. But so surface area is the area of the base. There's only one of them, plus half the perimeter times the slant height. Is that what I put? Oh boy. Oh, you guys, this is bad. This is slant height. So sorry. That is a big mistake. Okay. All right, so that's slant height. And then we know the lateral area would be this 1/2 PL. And remember, the base is regular here. Otherwise, we're going to use the net. Now the volume, you can just always use the volume formula. So the volume is equal to 1/3 times the area of the base times the height. Okay. All right, so everybody caught that this is supposed to be slant height. So sorry. All right, let's look at some examples. Okay, so we're going to find the lateral area, surface area, and volume of each solid. And we're starting with number 5, and then we will take a look at number 6, and then I think that's it. We just have the 2 examples to look at. So for our lateral area, we know that lateral area, the formula is 1/2 times the perimeter. Oh, and we can only use this if it is regular. So let's look at our base. Our base is 5 by 5. And then we've got 5 by 5. So that's a square, and a square is the regular quadrilateral. So we can use the formula. Okay, so we might just want to say regular base. So 1/2 P times L. And let's go ahead and let's just work that, okay? So the perimeter of our base is 5 plus 5 plus 5 plus 5, or 5 times 4 is 20. And L, remember, is the slant height. And that's the height that goes down the side. Like slant, think slide. You're going to slide down the top of the pyramid to the bottom. So our slant height here is 3.9 yards. So our lateral area is half of the perimeter, 20, times 3.9, which is the slant height. So, of course, I don't have my calculator, but half of 20 is 10, and 10 times 3.9 is 39. So our total lateral area is 39 square yards. Okay, now our total surface area, let's look at that. Our total surface area is the area of the base plus the lateral area, or that we already did that and we found that that was 39 square yards. So this base is square, which is really handy because it means we can use the formulas. And the area of this base is 25 square yards. So we've got this total surface area is 25 plus 39. And that is, I think, 64 square yards. Okay, and then we have our volume. And our volume is 1/3 times the area of the base times the height of the solid. Now the problem here is that we don't actually have the height of the solid, so we need to find it. So if you draw it in here, the height goes from the vertex and is perpendicular to the middle of the base, and then connect it here, okay? We have, what happens is you form a right triangle, and I'm going to go over here and use this space. And that right triangle connects to the gold part. Well, that was the slant height, and the slant height here is 3.9. And then we know that this is our height that we're trying to find. And then this length right here, well, it's half of a side length, because if you imagine that height dropping into the center of the pyramid, it would be half of 5, so this is 2.5. And this is a right triangle. So we're going to use Pythagorean theorem and solve for the height. So height squared plus 2.5 squared is equal to 3.9 squared. Okay, so I did some handy dandy calculations and got that H was 2.99, or about 3.0. So there's our height. It is equal to 3. Which is great, because now I'm going to do 1/3 times 25 times 3, and I can use the commutative property, and 1/3 of 3 is 1, and 1 times 25 is 25. So my total volume is 25 cubic yards. Okay. All right. So that whole idea of the pyramids, if you can, you might want to make one out of a piece of paper to make sure that you understand the difference of the height and the slant height, or I don't know, you might just want to find one around your house, because figuring that out understanding that is really important. Check this out. I learned that you can just, click clear your ink. Oh man, I'm such a old millennial. All right, I need to get with it. Okay, let's take a look at number 6. So on number 6, our base is a rectangle, and it is a 4x9 rectangular base. So this is not regular, which means when it comes to surface area and lateral area, we're going to have to use the net. Okay, but really that's not all bad, because the net of a pyramid is pretty straightforward. We have our rectangular base, okay, which is 4x9, and then we've got each lateral face, which is a triangle. So we have this lateral face, and this one has a slant height of 12.8, and this one has a slant height of 12.2. Okay, so they have different slant heights because our base is not regular. And then, we've got the other two faces that will be congruent to those. All right, so our lateral area is going to be the area of all 4 of these triangular faces if we unfolded this box. So we just need to find the area of each one of these triangles and add them together. So for this triangle, remember the area of a triangle is 1/2 base times height. So for this triangle right here, we need to do 1/2 times the base, which is 9, times 12.2. Okay, so the area of that triangle is 54.9. And then we know that this triangle is also congruent to it, so that's 54.9 as well. Then we need to find the area of these smaller triangles here. So these have an area that's equal to half of the base, and this base is 4 times the height, which is 12.8. So let's see here. 12.8 times 2 is 25.6 for our total area there, and we're in miles. So 25.6 square miles here and 25.6 square miles here. So our total lateral area is equal to the sum of those 4 faces. So 2 times 54.9 plus 2 times 25.6. So we add all that up for lateral area and we get a total lateral area of 161 square miles. Now for our total surface area, we just need to add in the area of the base because it's base plus lateral area. And our base is 9 times 4, so it's 36 square miles. So 36 plus 161 is 197. So our total surface area is 197 square miles. Okay, so we have volume left. All right, I'm going to erase. So if you still need to see that, you might want to pause right now. Let's see here. Okay, I don't think I need any of that. All right, now remember our height. So to find volume, we need 1/3 times the area of the base, which was 36, times the height of the solid. So our base is 36. Our height, we have to figure it out. So remember that height goes from the vertex and is smack dab in the middle. And then we can connect our height to whatever slant height you want. So because this side length is 4, dividing 4 in half is nice and easy. We get 2. I'm going to connect it with this slant height right here of 12.2. So if you can imagine, I have the height of my pyramid, which I'm trying to find, and then this length right here, the leg of my right triangle, is half of 4, so that's 2. And it's connecting to the slant height of my pyramid, which is 12.2. And so now we're going to do Pythagorean theorem and solve for the height. So we've got h squared plus 2 squared equals 12.2 squared. Okay, and when we solve for this, we get h squared is equal to 144. I don't remember, 8 or 08 or something. But anyway, when we take the square root, h is 12.03, which is about 12.0. So we're just going to use that 12.0. All right, so now we can find the volume. So we go back here. We say the volume is equal to 1/3 of 36. The base, the area of the base times the height, and 1/3 of 36 is 12, and 12 times 12 is 144. So our total volume here is 144, cubic miles, 144 cubic miles. All right, so remember how important knowing if your base is regular or not. If it's regular, go ahead and use the formula. Otherwise, for surface area and lateral area, you're going to want to redraw your solid as a net and then find the area of each of those regions separately. All right, dig in, have fun, do math, be good. I don't know what I was supposed to end that with, but that's what I'm ending it with. So have a great day. We'll talk to you later. Bye.